Okay, this is Unit 8, Lesson 4. It is going to be a two-parter. I'm going to have to stop recording shortly after we start, and it will pick up tomorrow for the next video. So on YouTube, this will be a part 1 and a part 2. This is going to continue replacement reactions, reactions and aqueous solutions, precipitates, and complete ionic equations. And again, it will continue onto another video. What I would expect to at least get done in this video is talk about complete ionic equations, or not complete ionic equations, a double replacement reaction is what I meant to say. So double replacement reactions. In these reactions, the equation example goes like this. AX reacts with BY to yield AY and BX. Now, this next part is going to be very important, everybody. A and B are positively charged. So X and Y are negatively charged. You notice that they just switch partners. You must be sure that you have a cation with an anion every single time. You can't have negative to negative. You can't have positive to positive. You're just switching dance partners. That's really it. Honestly, that's it. A is dancing with X, B is dancing with Y. They're switching. But you will not have A, B, and X, Y, because A, B are both positive, X, Y are both negative. So here is a couple examples. And this is going to be great practice for you to at least try to get the formulas right, okay? I give you calcium hydroxide and hydrochloric acid. You're just switching the dance partners, okay? Calcium is with hydroxide on the left. What will calcium be with on the right? You got A, B, oh, I'm sorry, AX, B, Y. So what will calcium be with on the other side? Chlorine. Now, this is where you have to really show your skills in balancing the actual compound. What is the charge of calcium when it's all by itself? +2. What's the charge of chlorine when it's all by itself? So what ratio will they balance each other out so they equal 0? So CaCl2. And then here's something that you guys haven't been taught yet, but I'm going to introduce it to you now. What happens, one of you will get this, when OH joins H? Think of that. OH joins H. OH and H. We're not talking about acids and bases. That's second semester. OH and H. Varun? Wait, what was that second thing you just said? H2O. So, I want to plant that seed in your brains. I'm going to try to just beat it into you day by day. OH plus H yields H2O. I want you all to say that. Say it with me. OH, come on. OH plus H yields what? Every single time. OH plus H yields H2O. Now, as far as balancing the equation is concerned, first off, let's see if you guys did this right. AY, BX, you did it. Now, if you were asked to balance it, we have a time to do that. Let's see. We have 2 hydrogens, 4 hydrogens. It's already balanced. No, wait. There we go. Now it's balanced. So that's a 1:2 to 1:2 ratio. Okay, I have you for 2 more minutes for today. Let me give you one more example. NaOH plus CaCl2. This is A, this is X, this is B, this is Y. Now, the mistake that most of you are going to make, listen to my words. Some of you will see Cl2 on the left. So you're going to think, oh, it's got to be Cl2 on the right. No. Just focus on the chlorine, all right? What sodium is dancing with hydroxide on the left. What will sodium be dancing with on the right? Chlorine. Now we need to figure out the ratio. What is the charge of sodium when it's all by itself? +1. How about chlorine? -1. So what ratio will they balance out, guys? 1 to 1. Plus, calcium is dancing with chloride on the left. What will calcium be dancing with on the right? What do you call OH? You had to know that. Hydroxide. CaOH. Now, what is the charge of calcium by itself? Hold on. +2. What about hydroxide? So you need to have 2 hydroxides. Okay. Let's stop there. We will continue.